Okay, it should be recording. So let's see if we can start this here. This will be the last live session. Do not hold a live session during week 6. So this is the last live session of the course. So here we go.
Has reportedly passed the Turing test for the first time in the history of the world and has become officially as intelligent as a human. For those who don't know, the Turing test was set up back in 1950 by computer scientist Alan Turing to determine whether or not a computer was artificially intelligent by having a panel of judges communicate with the computer through a keyboard. And if more than 30% of the judges were fooled that they were communicating with an actual person instead of an artificially intelligent computer, the device was said to be artificially intelligent. And allegedly, for the first time, a computer has passed the test in anticipation that has been expected to occur by many computer scientists and a horrific nightmare feared by many.
Okay, so that was discussing the Turing test by Alan Turing, and that was the result of some Russian programming and some Russian hardware. But here's the question. Is a computer really intelligent just because it appears to communicate? Maybe, maybe not. As we saw in this week's discussions, it takes more than just an ability to communicate. There were 4, 5, or 6 different criteria essential for an artificial intelligence. So let's go on to some of the other content this week. To the meeting. Share a screen. Let's share this one and go here. Talking about artificial intelligence. A lot of artificial intelligence processes use supercomputers and parallel processing. So what does that mean? Well, here's some information on some parallel processing. Here's what happens. The problem, instead of flowing sequentially, actually the commands themselves can be broken. And this has locked, look ahead, pipeline. And the pipeline, instead of moving in a linear fashion, will break parts of the job or the process out and run them in parallel. A lot of computers have been doing that for quite some time, and that's how that they call it multi-stage processing, or a microprocessor that can, they call it multi-process because it literally breaks the commands up and executes them in parallel at the same time. And when we use that process for the computers, now we really increase. And you can look at this. Here are some of the costs involved. $2 to $25 million for a supercomputer, 1 to 4, but guess what? Super minis, $20,000 or less. And these super minis, as they're called, they're not a class of supercomputers, can actually be achieved by linking and parallel processing much slower ordinary machines. So this paper that you would have been able, you can look at, and going to be interesting, but pretty boring. So let's get away from boring for just a minute. So what is this parallel computing? Serial computing, then, serial computation, one step after the next, after the next, after the next. So this is the way serial works. In 1, 1, 1, 1, 1, and then process. 1, 1, 1, 1, 1, process. But here we go. In parallel computing, the question or problem itself is broken into pieces and then follows a series of processes that now go, how fast can we conduct this part, this part, this part, this part, run them all in parallel. Okay? Here's a picture of a parallel processor. The ways this can be applied to networks. In other words, you can connect multiple standalone computers to make a parallel computer cluster. The very same thing as I just explained, by using older hardware and connecting them to work in parallel on a network. And I think if I can work down this a bit here, these are the percentages of the people that have I'm talking high-end parallel processing. And what do we get out of it? We get out of the ability to model things such as climates, weather, earth movement, planetary movement, traffic, assembly, all of these things. Parallel processing saves money. It saves time. It allows things to handle more efficiently and effectively. And this is the result of some of these where it says how quickly things can improve. That's this much faster using parallel processing and parallel computing. These are some of the aspects of it. Okay. All right. There's another picture down here I'm not going to get to. Maybe I will. Let's see if we can do that. Okay. For example, this was one of the original size computers. I had them like that when I was in college the very first time. And then they went to things like this. I've worked on things like this. And then the Crays. I've worked at a couple of places that had Cray computers. Those are supercomputers. And I worked on the PDP 11, not a PDP 1, but a PDP 11. All right, so that's a little bit about parallel processing and some of the machines that attempted to use it. So let's think about something else. So here we have all these wonderful computers. What do we do when they get old? Well, we throw them away, right? That does not help. Throwing them away does not help. For example, Apple Computer will actually accept any old computer, and if it works and it has any value to it, they'll give you credit towards an Apple device. So you can take your junk computer down to Apple, and they'll take it and recycle it. And there are programs, there are retailers that recycle. That's what we just talked about, such as Best Buy and Staples. Some public programs that will recycle. Manufacturers, they talked about Dell, Lenovo, Apple. See right here, Apple provides free recycling for any brand of computer. Isn't that neat? No need to have that old, antiquated stuff occupying space. And here's the deal. Why are we really worried about computers and recycling? It's this. Two issues. One, the information needs to be cleaned off of the machine. The second one is a lot of the components of a computer they're rare metals, rare earths. They literally can poison the ground. So you want them to be recycled. You want to take care of what you have and prevent any damages or injury even to yourself, not just other people later on as well. So there we go. Recycling, parallel computing, which was really fun, fantastic thing to work with. Really, really good outcomes from that. And then the parallel computing article here. So I've enjoyed having these sessions with everybody. I wish you continued success and have a great time. Now let's see what we can do here. Stop the video. Pause the share. End the meeting.